Well, welcome viewers. Here today we're at Penrite's head office in Wantirna. This is their main blending factory out of 3 blending factories that they own and operate. Today we're actually going to go behind the doors and have a look what it takes to make a modern oil. The first place we're going to head for is the laboratory. I love the lab. They're like mad little chemists mixing and matching oils. That's the first place we were heading for. Let's go on in and check it out.
Hi Ken, welcome to Penrite. Go on in.
Thanks, Chantel. Well, here we are in the heart of Penrite's lab. This is where it all happens. As you see behind me, there's a lot of equipment in here, and it's a bit beyond me. So I'm actually going to hand you over to John Firth. He's the man who's got his finger on the pulse around this place, and he's going to explain what's going on.
So here we are in a typical lab of a general oil blending company. Within inside a lab, you have numerous pieces of equipment and testing machines that simulate or test according to what you actually want to make or test against. One of those things is obvious viscosity. That's what the engine oil has. It has numbers on a bottle which relate to the pumpability and flow of the oil at cold temperatures, and also the protection it gives once it's operating. This machine behind me here is what's called a cold cranking simulator, and that actually simulates exactly that. When you start an engine in the morning, the oil has to flow. And what determines that flow is the thickness of the oil. This simulates exactly that. So we test an oil at minus temperatures. For example, a common viscosity would be a 20W50. The 20 is that cold start number. So we simulate in this machine here exactly that, minus 15 degrees Celsius. We put the oil in, we'd run the machine, and it gives us figures at the end that hopefully the oil comes out in a parameters of numbers that will give us a figure that actually determines the 20W oil. The second number, the high temperature protection, is actually tested at other machines at different tests. Alright, so what we have here is actually 2 beacons with, first of all we actually got pure base oil. So it's plain, hasn't had any additives touched to it yet, and it's what's called 150 neutral base. And you can see by that it's clear as water. So it's actually very, very pure, which means obviously all the solvent and everything else being taken out. And then we look at this product here, and this beaker is actually a product that's actually started with a clear base oil as such, but then it's been through the blending process and had additives added to it, and probably a dye as such, and it's get now what you call traditional oil colour that we expect to see every time we pull it out of the bottle. So you can see that oil is actually clear and pure once it's in its initial refining stages. So what we actually have here is this machine is called a consistent viscosity bath. In other words, it's actually measured or heated up to a temperature of 40 degrees C, and we take 2 measurements for a viscosity. So the second number, your high temperature protection, which is, for example, an equation of a 20W50 to 50. And we test it here by having a mark at the top and the bottom, and the oil that's tested is we time it how it runs between the top and the bottom point with this stop clock here, and that time is then recorded against on this sheet, and then we transfer that into a calculation to make sure it reaches the parameters which we need to meet. That's the 40 degrees test. Then we also do another one at 100 degrees, and that's a high temperature test, which is done in a separate machine over here. So we've seen the 40 degrees machine. This one here now is actually set at 100 degrees C. And what this actually simulates, and we test for, is actually the operating viscosity of the oil, so the thickness of the oil at operating temperatures. So, and actually when you test against this machine here, the rate in which the oil will flow is actually a lot quicker than at the 40 degrees. And the reason for that is as the temperature increases with the oil, the viscosity thins, and therefore the oil will actually flow quicker. So this is actually simulating the drop in, or the increase in flow rate of an oil at operating temperatures. Okay, so part of everyday business within an oil company is obviously the manufacture of general blends and everyday products which we test and record against certain parameters. But also another part of it is R&D, research and development. What we actually have here is 2 blends, experimental blends, maybe for certain specific applications that we've had requested. And what this machine does here is actually simulates a larger blender, which we have obviously in our production plant. But when you're doing a test blend, you don't want to have thousands of litres wasted. So we actually have a simulator here that simulates a blending paddle, a heating pad, which actually heats the oil as well. And as it's currently blending, it's mixing the product accordingly. And this will go on for probably, maybe 20, 30 minutes. And then once that's blended to time and scale that we require are then actually taken away and tested in the same way we actually normally test a normal blend. So what we have here is a machine what's called a spectrometer. And a spectrometer actually tests the percentage of metals in an engine oil, or any oil I suppose. For example, an engine oil is made up of base oils and additives. And some of those additives may be anti-wear additives, which is predominantly zinc in most blends, a detergent which helps clean, and also friction modifiers. So when we do this test, it actually picks up from the sample here, runs it through and scans the percentage for, say, anti-wear would be zinc and phosphorus, or a detergent would be calcium and magnesium. And those levels and percentages in an oil are tested in here, and the results come out on the computer screen against certain parameters which a certain oil blend has to meet. And we can then look at those results, print it out and compare it against our raw data.